Understanding the basics of material science for beginners. Material science is a branch of science that deals with the study of materials and their properties. It is vast and diverse, covering topics from biology, physics, chemistry, and engineering. Understanding material science is essential, especially for beginners, as it can help one understand the various types of materials that exist and how they are utilized in different fields. In this article, we will be covering the basics of material science for beginners. The structure of materials. At the atomic level, materials are made up of atoms that are bonded together. The arrangement of these atoms determines the properties of that material. Crystalline materials, for instance, have atoms arranged in a specific pattern, while amorphous materials have their atoms in a disordered pattern. The arrangement of atoms in a material has a significant impact on the material's properties. For instance, solids made of tightly packed atoms have high density and are heavy, while solids made of loosely packed atoms have low density and are lighter. The properties of materials. The properties of materials refer to their characteristics that make them useful in various applications. These properties can be divided into two categories: physical and chemical properties. Physical properties include 1. Density. This refers to the mass of a material per unit volume. It usually depends on the material's structure and the packing of its atoms. 2. Melting point. This is the temperature at which a material changes from a solid to a liquid state. It varies depending on the type of material. 3. Hardness. This refers to the ability of a material to resist deformation when subjected to external forces. 4. Electrical conductivity. This is the ability of a material to conduct electricity. It varies depending on the type of material. Chemical properties include 1. Reactivity. This refers to the ability of a material to react with other substances chemically. 2. Corrosion. This is the degradation of a material due to chemical reactions with its environment. 3. Flammability. This refers to the ability of a material to burn when exposed to a flame. 4. Toxicity. This refers to the degree to which a material can cause harm to living organisms through exposure. Classification of materials. Materials can be classified into four main groups: metals, ceramics, polymers, and composites. Metals are materials that have metallic properties such as ductility, malleability, and electrical conductivity. They are widely used in various fields, including construction, transportation, and manufacturing. Ceramics are materials that are hard, brittle, and have excellent compressive strength. They are also resistant to wear, corrosion, and high temperatures. Ceramic materials are used in applications such as electronic devices, automotive components, and biomedical implants. Polymers are materials that have long chains of repeating units. They have a wide range of properties, which can be tailored to meet specific requirements. Polymers are used in different applications, such as packaging, textiles, and medical implants. Composites refer to materials made from two or more different materials with the aim of combining their properties. Composites are widely used in various applications, including aerospace, automotive, and construction. Material processing techniques. Once materials are classified and their properties understood, the next step is to process them into useful forms. Material processing techniques include casting, forging, welding, and extrusion. Casting is a technique that involves pouring a molten material into a mold, where it solidifies and takes the shape of the mold. Casting is used to make objects such as gears, turbine blades, and In blocks. Forging is a technique that involves heating a material to a high temperature and then shaping it by applying a compressive force. The technique is used to produce parts such as gears and shafts. Welding is a technique that involves fusing two material pieces or parts together using heat. The technique is used in various industries, including construction, automotive, and aerospace. Extrusion is a technique that involves forcing a material through a die, which gives it a specific shape. Extrusion is used in various applications, including manufacturing of plastic pipes and alumi. New tubing. Furthermore, material science research is ongoing and constantly evolving, with new materials and applications being discovered and developed regularly. As technology advances, the need for materials that can withstand various conditions and perform specific tasks increases, driving the demand for innovative new materials with unique properties. One example of this is the development of new carbon-based materials such as graphene, which has remarkable strength and conductivity properties. Graphene has the potential to revolutionize various industries, such as electronics and energy storage. Moreover, material science plays a critical role in sustainable development and environmental protection. Finding materials that are eco-friendly, recyclable, and energy efficient is crucial in reducing our impact on the environment. In recent years, there has been a significant focus on developing materials with properties that can aid in minimizing environmental impact and boosting energy efficiency. For example, there has been a push towards using materials with a low carbon footprint, such as biodegradable polymers for packaging and energy-efficient building materials. One of the most exciting and promising areas of material science is nanotechnology. Nanotechnology involves the design, production, and manipulation of materials at the nanoscale, 1/1,000,000th of a meter. Materials at this level exhibit unique properties that can be harnessed to create new technologies and materials. Nanotechnology has the potential to revolutionize various industries, including medicine, electronics, and environmental engineering. For example, nanoscale materials can be used to develop new drug delivery mechanisms that can target specific cells or tissues, improving treatment outcomes and reducing side effects. In electronics, nanoscale materials can be used to create smaller and more efficient electronic components, leading to faster and more powerful devices. Additionally, nanoscale materials can be used to develop more efficient and cost-effective solar cells, leading to increased adoption of renewable energy. One of the challenges of material science is designing materials that are both strong and lightweight. This is a critical issue in industries such as aerospace, where fuel efficiency is a major concern. Researchers have been exploring the use of advanced composite materials to create lightweight but strong structures. Composite materials are made by combining two or more materials with the aim of maximizing their benefits while minimizing their weaknesses. For example, combining carbon fiber with polymers can create a material that is lightweight, strong, and resistant to wear and corrosion. In addition to designing new materials, material scientists are also working on improving existing materials. For example, the development of new alloys and manufacturing processes has led to significant improvements in the strength and durability of metals. Furthermore, material science is also critical in the development of new manufacturing technologies such as 3D printing. 3D printing allows for the production of complex structures and shapes that we